to thank those who have joined us, and to thank Esther for her help in advertising this event for everybody, and of course, including our speaker, Professor Gavin T.L. Brown, for your flexibility, as we work to reschedule this event a couple of times. We're recording it. I can see that's kicked in now as our official time has started. And, this will be available to those who weren't able to join us in this time slot, but might be able to view it later. This is this seminar series is part of the Psychological Studies and Education Social Work group. This is a kind of a cross-faculty, strongly within faculty and the Faculty of Education and Social Work group that is interested in and doing scholarship on psychological factors as they affect education or well-being. We are delighted today to start our first seminar of the series for 2020 to have Professor Brown with us. He's been a colleague and a mentor of mine for 8 years since I moved here in 2012, and I'm grateful to him for being that mentor to me and for being our inaugural speaker. So without further ado, Gavin, welcome.
Thank you very much. If you wanted to see the slides, that URL on the front screen is where a PDF of these slides is available, and you can download it from there and annotate it if you wish. So you don't have to scribble everything down quickly. More importantly, if you really want to know what this lecture is about, you could read this book. This book is open access, so it's one of those rare books that you can download the whole book from Springer Open. And everything I'm going to tell you is written in detail and full expansion there. The project was led by my colleague Michalis Michalidis at the University of Cyprus, and I worked on this while I was on sabbatical last year in Sweden, where I worked with Hanna Eklöf. And I got a chance to go to Cyprus and meet up and meet my colleague Elena Papanastasiou. And there was a call by IEA for people to do new explorations of TIMSS data. TIMSS is the Trends in Mathematics and Science Study. And they asked for people to propose new studies that wouldn't just be variable driven, where you linearly correlate or regress variables. They wanted something different. So I said to my 3 colleagues that why don't we do cluster analysis, just simple, boring old classical cluster analysis at the data, of the TIMSS data, and we negotiated, and the IEA not only paid for this book to be open source, but they also paid us 25,000 euros, which we shared around, and Michalis used it to pay 2 research students of his at the University of Cyprus to do all the donkey work of crunching numbers. So this was a really good deal, and I really want to acknowledge their contribution and the funding, and to say that I didn't do the donkey work, I just did the big idea work. And that's what I'm going to hopefully contribute to you as well. Theoretically, in educational psychology, we argue that various motivational factors contribute to academic success. If you're confident, you are sure that you can do it, that is associated with greater outcomes. Self-efficacy is another way of describing confidence perceptions. Thinking something is valuable means you invest energy and effort in it, and you probably do better because you think it's valuable. And enjoying, liking, having interest in whatever you're doing is also traditionally be found to be useful. So often teachers will talk about it's important that kids enjoy or like my subject. I want them to understand how valuable it is, and that will help them do better. And so that's a pretty standard set of assumptions in educational psychology. And lots of people have been running studies where they've operationalized these things into self-report instruments and correlated or regressed them onto achievement. In fact, in John Hattie's visible learning, he found that, yes, there's a positive correlation between these attitudes and achievement. And it's been characterized as positive and strong. I have to say I'm not so sure about the strong part, but definitely I agree with the positive. Empirical work, especially from PISA and TIMSS, which do large-scale studies internationally in multiple countries, finds the values to be weak rather than strong. And here's some of the numbers. So you can see we've highlighted confidence with math, and you can see the values 25, 21, 21, 39, 39, 37. So they're not very big. Positive affect, having a positive feeling, 0.07, 0.01, 0.25, 0.22, even smaller. Valuing math, negative 04, 03, 08, or 16, 12, and 15. So this is one that either is very weak positive or very even weaker negative. And so you can see the general effect sizes for self-beliefs, like I can do that, tend to be positive, but only in the range of 25 to 30, which is not a big effect size. Positive emotion or affect is less than 0.05, but it's positive. And value looks like a negative effect on achievement. So maybe these things aren't as all-powerful as we would like to believe them, and teachers and parents are misplaced energy if they try to persuade kids, you need to like it and you need to think it's important. So, what are some of these theories that TIMSS itself has drawn on? TIMSS has been running since 1995, and one of the things we found in reading the TIMSS documentation is it's not being consistent or clear which theories they're using when they collect this data. Self-determination theory gets mentioned, self-concept gets mentioned, and self-efficacy get mentioned. Expectancy value theory is not mentioned, but it looks like some of the items that they actually have in the TIMSS study. And achievement goal theory also is not mentioned, but it sure looks like some of the items. So these, what I think I would like to say about this, and this is Jason's field much more than mine, is that lots of terminology gets used and a lot of overlap when you look at how things are operationalized. There are distinctions, but operationally in TIMSS, it's a bit of a blur and it hasn't always been clear.
The jingle jangle, yeah.
Yeah, sometimes it's jingle jangle and sometimes it's just we weren't sure and we just grabbed something. So how does TIMSS has operationalized 3 constructs that we were able to find in grade 4 and grade 8. In grade 4, they only had confidence and enjoyment. And in grade 8, they had confidence, enjoyment, and value. And they've been consistently allowing students to select on a 4-point scale a degree of agreement. Well, the good thing about that is there's no midpoint of I don't know, I don't say, or I'm neutral, but maybe there's a lack of variance in the data. And the examples I'm going to show you are from 2015, which is at the time we were writing the book, the most recent data. But we also collected and analyzed data from 1995 and 2007. So there's actually 3 cross-sectional slices in this book. And there are 12 countries that we found had administered these items in all 3 time points. So these are the enjoyment questions. And they're fairly standard questions that you would answer. Hopefully, if you say, yes, I enjoy, you answer, no, math is boring. So it's a kind of check to make sure you're not just going, yes, 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 yes to everything. This is what the confidence items look well. It's a mixture of self-efficacy, I'm good at working out difficult mathematics problems, to I usually do well, which is a much more general thing rather than a specific thing. Uh, it's kind of self-efficacy. My teacher tells me I'm good at mathematics, getting that vicarious input from somewhere else. But these are all how the person rates their own ability in math. And value, this is the one that they don't give to grade 4. They only give it to grade 8, and that would be an interesting question to know why they didn't give it to grade 4. Maybe they thought this thinking ahead was too early for kids in grade 4. But you can see it's a forward-looking thing to the importance of mathematics in society and in my personal life and for employment and the rest. So the problem is at best, the relationship between these 3 motivational variables in achievement is either weak or moderate. And maybe the problem is that people have mixtures of beliefs, that they're not consistent. They don't consistently have positive motivation, positive affect, and positive confidence. Maybe they have mixtures. I think math is important, but I don't like it, and I'm not very good at it. That's highly probable. And maybe it's the fact that a lot of participants have mixtures of these motivational values that results in the variable having only at best a moderate relationship with achievement. So this data set from TIMSS with its background variables that the students answered and a robust achievement score allowed us to take a person-centered approach. Instead of looking at the variables and their relationship, let's look at how the people cluster around these 3 constructs. So, oh, someone's underlining this? I don't know where this underlining came from.
Yeah.
Anyway, to examine. So we wanted to know whether there were meaningful profiles that we could take out of the data. And we were deliberately trying to find beyond everybody's high, everybody's middle, and everybody's low on these 3 variables. We were actually looking to see, is there any evidence that there are people with mixtures or blends that weren't consistent? And whether there was a relationship, if you have a different profile than a consistent one, which mixed profile is associated with better or worse achievement? And we want to know who's in the cluster. If there is a cluster of high value and low confidence and low liking, who are those people? Are they different in these different clusters? And we had access to the sex and some measure of the home resources and their amount of time they spend on homework inside the TIMSS data set. And we wanted to see whether, once we put you in a cluster, what can we say about being in that cluster? So this is secondary data set, and all the data is open access available from the IEA. You end up in TIMSS at Boston College when you search for their data sets, and their data sets are available. And we ended up with 12 jurisdictions. I was disappointed that New Zealand did not participate in one of these 3 rounds, so we couldn't include them. But we had 12 countries that participated, 12 countries, I should be careful, 12 educational jurisdictions that participated in this. In Canada, it was Quebec and Ontario, because Canada, like the US and Australia, has a federal educational system, and so those provinces participated, and it would be meaningless to say Canada anyway. So this is our sample set, and the highlighted ones are the ones that I'm going to talk about I'm just going to talk about the grade 8 from 2015. But you can see there's a lot of people in these 12 districts. And some of these countries are kind of small and relatively obscure, like Slovenia. Hong Kong is actually not a country. It's a special administrative region of China. Singapore is a city that's a country compared to USA, which is 330 million people. And so it's a real mixture of different places at these 3 different time points. So the variables that we were using in 2015, the 3 constructs: students like learning math, students are confident in math, and students value math. And because these are 4-point scales, TIMS had already pre-analyzed them for us using item response theory partial credit. So that means if you choose, so they were creating factor scores out of the set of items and scoring those based on the strength of how strongly you had selected those items using item response theory. So they had already given us a set of scores for them. For math, they had already processed the math scores with item response theory. Now you have to remember that people in TIMS don't do all the items. They do a booklet of items, and there are multiple booklets of items. And so there's lots of planned missing values. So I do this set of items, you do a different set of items, but we have to link us together to get a score on a same scale. So there's a process of, given that there's missing data, we use this item response theory way of creating plausible values, estimating what your value would have been if you'd taken all the items, which you clearly couldn't do. And so they create 5 different plausible values. And the IEA has a database and a software system that allows you to exploit the 5 plausible values simultaneously. Obviously, what the child wrote as their sex, and they were only given a choice of boy, girl, or male, female. They wouldn't be given the modern thing of I don't want to say or something else. And then for the home education resources, TIMS creates an index based on how many books do you have in your home and what kind of home study supports you have. Do you have your own room? Do you have an internet connection? And how educated are your parents? And these become an index of socioeconomic status. And we wanted to know whether that had colored the clusters that we would get from using the first 3 variables: value, confidence, and liking. And so we used a very exploratory technique using cluster analysis, and this is properly called classical cluster analysis because it's been around for a long time. And cluster analysis is, we don't know what the curves are, so we're going to throw the data into this estimation tool and see what comes out and see if the clusters make sense. And hierarchical cluster analysis is a procedure that looks to say which entities are closest to each other based on their responses to certain variables. So it looks at the variables and says these entities have high similarity, and it displays that in the dendrogram. Dendo from a dendrogram, it comes from the Latin dendo, meaning tooth. And so it's a tooth-shaped thing. And the smaller, the closer the gaps. So what you can see in the diagram is the blue are very close and very similar to each other because there's a very small height difference. But to get to these ones in the pink, you have to go back up all the way to the top and then back down. And so, and this second group, so you could split the US into 2 groups. Group 1 made up of this, which splits into 2, and group 2, which is made up of these ones. And it would be interesting to know what variable led to those being grouped that way. So it's purely, let's look at it and make a judgment call, okay? So it's very descriptive and very eyeball. And it's using what's called a Euclidean distance of how far from our friend, the Greek mathematician Euclid, how far are these things from each other on the variables I gave it. K-means clustering is similar, except it can use continuous variables and large data sets. Usually you define how many clusters you want in advance, which is problematic because how many should there be? Given that we have 3 variables, you would expect one cluster to be high on everything, a second cluster middle on everything, and a third cluster low on everything. So we could specify at least those 3 clusters, but I could also imagine high on number 1 and not high on 2 and 3, high on number 2, not high on 1 and 3, high on number 3, but not high on number 2 and 3. So that's 6 clusters I could imagine, so I might use that. What we did is we used the 2-step process, which is a kind of have your cake and eat it approach, which uses continuous and categorical variables, but in this case we're using 3 continuous variables, and it uses a hierarchical method using a log likelihood instead of Euclidean way of estimating distances of people to each other. And so we ended up with clusters for grade 8, and we used that as a basis, partly because there were 3 variables that we used to cluster. So different numbers of clusters are going to come out depending on how you design the analysis and what you choose to do. So what we did is we ran it initially with just 2 or 3 clusters, and what we got is what we expected. Cluster 1, high on everything, cluster 2, moderate on everything, and cluster 3, low on everything, and that was kind of boring. So we said, let's open up the number of clusters, let's increase the number of clusters, but let's make sure the clusters aren't too tiny, because that's not going to be very informative. So we systematically tested between 3 and 6 clusters in every jurisdiction. So 3, 4, 5, 6, so that's 4 cluster runs times 12 countries times 3 data rounds. That's just for grade 8. Double it for grade 4. So you can understand why Michal has hired 2 research assistants to help do all this work. It's a lot of runs. And so we had this statistical measure, the silhouette measure, as an indicator of how good the fit was. We said that we didn't want super small clusters, so we said every cluster had to be at least 7%. And we were interested in whether there would be mixture clusters and whether we could interpret the cluster. Because you're looking at it and you're going, well, that's low, low, high. Does that make sense? Can we interpret that? So we ended up with all of these clusters, and when we weren't sure, the 4 researchers on the title of the book debated and discussed and brought in agreement with each other as to which solution made more sense. And because we're nice people, in the back of the book is the syntax for how to do this in SPSS. I'm not going to belabor that. So once we had clusters, we then ran pairwise comparisons of achievement on each cluster and on the home education resources. So we ran this, and we could get weighted statistics and corrected standard errors using the IEA IDB analyzer. Now, this is a free tool that works with all international large-scale assessment data sets that have those multiple plausible values. So you can download the IDB analyzer. My colleague Michalis got paid from the project to go to IEA in Copenhagen and taught how to use the IDB analyzer. And it's got special tools in it to handle the weighting of the plausible values and correcting the standard errors for the mean achievement and for the home education resources. So we could use that tool. And then we ran a simple chi-square test for independence. Is the proportion of boys and girls in each cluster different? And so we used percentages, so 48% boys, 52% girls in cluster 1, 49-51, 50-50, 50-51, whatever the number percentages were. And we asked, are these different by more than would occur by chance? And then we plotted box plots of the 3 variables that we're using to define the clusters. And you need to keep in mind, the dark one is enjoyment, liking. The gray one is self-confidence. I'm sure I'm good at this. I am good at this. And the white one is, I think math is important. It's valuable. And so here is Australia. Now, I'm not going to show you all 12. I picked a few. And we'll work our way through 1 or 2, and then you can read the book. So when we look at cluster 1, we see, well, that cluster 1 looks, everybody had a pretty high score on all 3 variables. And if anything, you couldn't really say value was lower than interest because they're really overlapping. Cluster 2 looks like confidence is higher than the other 2 and value looks lower. Cluster 3, value looks higher than the other 2. Cluster 4, it's kind of, again, a higher for value. So cluster 3 and cluster 4 look higher for value, whereas cluster 2 and cluster 1 look higher for confidence. I'm sure I can do this. So there's 2 kind of groups. 1 and 2 look high on I can do this, and cluster 3 and 4 look higher on, yeah, this is valuable, and cluster 5 looks like the group that don't like anything. They're the low group. And in the table 4.13, you get the statistical information about each of these clusters. So you can see that cluster 2 is the biggest cluster. Cluster 3 is the second largest. Cluster 4 is reasonably large. So cluster 3 and 4 were those 2 groups where they were high on value, and that's 49% of the Australian sample of grade 8 students in 2015. So almost half the Australians are in a group where, whether they're moderate or low for enjoyment and confidence, they're higher on liking, value for math. The second row in the table is the average value, and the letter A, B, C, D shows you that whether the score is different by more than a statistically significant margin. And so A in cluster 1, the high group is high, gets the highest score. The B group, it covers cluster 2 and cluster 3. So both of them have the same sort of score. But if you look at cluster 4, where the scores drop, but value is highest, you get a much lower score. And our poor kids in cluster 5 who aren't interested, don't think they're good at it, and don't think it's very valuable are the worst performing kids. So in that sense, there is a general trend that having high values is associated with high scores. But notice the group 2 and group 3 have very similar scores, but very different values for value. So that's an intriguing oppositeness. When we look at what percentage of girls is there, look at the difference between cluster 1 and cluster 5. Cluster 1 has only 40, not even 40% girls. It's the boy group. Cluster 5 is 2/3 girls. They're the girls, that's a group of girls especially who are completely turned off math and don't do it very well, which is a scary thing. And that perhaps is the stereotype girls aren't good at math, is maybe based on this 8% of girls, 8% of kids, 2/3 of which are girls, that just don't completely switched off and don't do well. In between, what's interesting is in group 4, which is a low performing group but has high value, what you see is there's a lot of girls, 60% girls. The amount of time spent on homework didn't vary between these groups beyond chance, but how rich mom and dad were at home did vary. Group 1, cluster 1, the high score, high value everything, had the most, and group 5, lots of girls, low achievement, low attitude, had the lowest scores. So is it they're switched off because of some issues at home rather than being girls? Nonetheless, this is an interesting pattern, which we wondered, does it replicate? So let's look at Quebec, which is the province I'm from. We ended up with 5 clusters again. Again, the clusters are reasonably, the first 3 clusters are close to 1/4 of the population each, and the last 2 clusters are more 10, 12%. This time, it's the cluster 5 clearly shows I can do it and I don't care, I don't necessarily like it very much, and I don't think, it doesn't matter to me that it's important, but I can do it. And when you look at cluster 5, it's a small group. It's a little bit below average in girls, and it's a pretty high scoring group. In fact, it's the highest scoring group. And then as we look down the row, as we go back across clusters 4 and 3, we see the scores going down. Cluster 4 is a mixed profile, super high on value and moderate on I like it and I think I'm good at it. And what does cluster 4 look like? It's another small cluster. They didn't do too badly. They're in the second group, 559. Not too many girls, and reasonably wealthy, 11.1. Not a big difference there. When we come to group 2, what we see is a group that's very high on I'm sure I can do it. And that's 24%, slightly below expectation in girls, pretty good score, and reasonably wealthy. And then when we see, so we're seeing there's seems to be this kind of thing, if you're sure you can do it, you actually can do it. So that's a nice thing, that their self-efficacy seems to be justified. On the other hand, groups with lots of value, like look at cluster 3, strong on value, that's their strong suit. And cluster 3 is low on it, not the lowest, but lower on achievement, and high proportion of girls, nearly 60% girls. Hong Kong, only 4 clusters this time. And the clusters look much more consistent except for cluster 4. Cluster 4 is a moderate cluster with low value. They don't care whether math is valuable. And what do we see when we look at this group? It's only 32% girls. It's a high score, 631, 632, which is the highest scoring group. And they are moderate for, highest for home resources. So it looks like you can do well even when you don't think math is valuable. But if you do think math is valuable, like you can see that in cluster 3, that's the group that thinks math is valuable, what do we see there? They're still pretty good, 632. There's 20% of the population, and again, it's only 32% of girls. So, girls in the high ability, high efficacy groups, I can do this, are low. There's not many girls. Instead, the girls tend to be in the groups, in Hong Kong anyway, where there's low or moderate responses for all three motivational variables. Iran was an interesting country because the sex distribution didn't have the same split. What you can see is if you look at the two clusters with the most girls, 52 and 54%, cluster 1 and 2, you can see they're pretty consistent. These are low moderate. The high value group, cluster 3, has only 47% girls. So unlike the two previous groups, this group where you have high value is not colored by being mostly girls. And the research we did in reading up on this, there are publications which suggest in a country like Iran where the sex roles are very constrained, the societal role of women is much more constrained and traditional in Iran. The way to get ahead is to be good at STEM subjects. Whereas in more open societies where girls can do anything, it seems that fewer girls go into STEM subjects because they don't have to go into STEM subjects to get ahead. So it's an interesting result that we found after we found this result. Look at cluster 4. This is the group that I like math. I think I'm good at math, but I don't care that it's valuable. Cluster 4, how did they do? 493, which turns out to be the highest score. So thinking math is valuable doesn't seem to be associated with doing good at math. Norway, a nice, enlightened, modern Scandinavian country with lots of tolerance for girls. Let's have a look at what do we see. What you see is 6 clusters instead of 4 or 5. We're back to 6, and what we see is lots of mixture clusters. You can see, like in cluster 5, only confidence is high and the other 2 are down. In cluster 2, liking is down. Cluster 1, liking and value are down. So there are many more mixtures. But let's look at the 2, 3 clusters that always have I can do it highest. That's cluster 5, cluster 6, and even cluster 1. How do they do? Well, cluster 5, 523, cluster 6, 535, and those are the 2 highest scores, and then cluster 1 comes in at second. So the 2 clusters with the most scores are high on confidence and either moderate or lower on liking, interest, and value or importance. So doing well is associated with confidence, which actually is justified here. And there is a group that has value as the highest, that's cluster 4. And what you see is second range score, 480, a shortage of girls, 47%. So this is Norway behaves differently to the other 2 groups I've highlighted. Singapore, another Asian group, again, 6 clusters, lots of mixture clusters. And where you see the mixture first off is cluster 2. High on I like it, high on I can do it, but I don't care that it's valuable. What did cluster 2 do? It's 666, which happens to be the highest score. So consistently, as we were reading through these things and looking at the information, what we kept seeing was as long as you thought you were good at it, you actually were good at it. So the question is, of course, chicken and egg. My idea is you are good at it, and so your confidence is justified. Is there a cluster that had really low value? Not really, but there is a cluster, number 5, where value is highest, amongst the 3 low ones. How did cluster 5 do? The lowest score, 559, and 52% girls. Slightly more girls into this idea of value. So there's some interesting, we can't, when you're comparing this way, it's really hard to say this is a solid association, but I can assure you by the time you've read the book, you'll see this pattern seems to be coming up time and time again over the 20-year period of data and across these 12 countries. Cluster 4 should be the high scoring cluster, and cluster 3 and should probably be pretty good. Cluster 2 is probably not so good, so let's test that hypothesis. Cluster 2 is 494, and cluster, what did I say, 4 and 5 and 3 should be better. Well, 3 is better, 4 is better, 5 is better. So it turned out cluster 2 was the lowest achieving group, where they were moderate for liking and moderate for I can do it, and really much higher on I think it's valuable. So based on this snapshot, what you can see is that students seem to be, there's always a cluster in every society that we've evaluated where there were high, 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 middle, 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 and low, low, low kids. And the high group, where you were high across all 3 things, tended to be the best performing group. We found inconsistent profiles everywhere except the Hong Kong group. The Hong Kong group did not give us consistently that mixed profile. And the usual mixture was students who were high for value and lower on confidence and enjoyment. And it was that group that always did worse. And there usually was another group that were high for confidence and enjoyment, but low on value. And that group, as long as they were high on self-confidence, they did better. So more, and it seemed reasonably consistent that there were more boys in the clusters with high self-confidence. As long as there was high self-confidence in it, there tended to be more boys. This may be a stereotype that boys just overrate themselves. Boys think they can do everything. But Iran was that exception. But it's interesting, if it was just ego enhancing, why did they actually perform better? Which is the interesting thing. They had high self-confidence and high scores at the same time, rather than just ego assuaging or ego maximizing high confidence while being dumb. Clusters with the high motivation scores tended to have high math scores and higher home resource scores. So that really makes me wonder, what are high resource homes doing before kids get to school that gives them that leg up at school and which school keeps adding to? And if you read the Coleman report from 1966 in the US, you'll find that home resources really do make a difference. Parental education and resources really do give kids an advantage, and that's what we see too. Value is a problem for us. It's an external type of motivation as opposed to internal or self-efficacy. And when it overlaps, it relates to achievements, but there are always clusters of students who reported high value and lower. And we would say getting kids to believe that math is valuable is not a bad thing, but it doesn't help them do better. Knowing that Einsteinian physics is valuable doesn't make me good at doing it. So we have to stop seducing teachers and parents and kids into thinking that knowing something is valuable is enough. That's clearly the evidence in our book says that isn't enough. Um, you could be self-confident and enjoy it at the same time, but it didn't always overlap. But what we found is it was self-confidence that was more associated with better achievement than enjoyment. So the second take-home message for me is mom and dad and teacher, don't be seduced because they like doing it. What we need to see is they're actually doing harder stuff, not enjoying doing more of the same or more of the easy stuff. And I have a suspicion that in schools it's easy to keep kids happy by getting them to like what we're doing instead of actually trying to do harder stuff. And what we found is that being positive about your confidence was adaptive and was associated with high achievement. And I've used the word veridical, which is a very fancy word to mean truthful, verifiable, justified. Kids with high self-confidence who really can do complicated and difficult things and do harder things have a justified self-confidence, which we ought not to knock. We should be encouraging that. Hey, you're good at that. Move on. Do some harder stuff now. So, justified confidence, students with stronger endorsement of this rightly believed that they could do math because the means were higher for those groups. And they achieved higher scores than their colleagues, their peers who prioritized value over enjoyment. So for me, what does this mean for teaching and parenting? It says that having a sense of confidence, independent of real capability, is not going to turn you into a capable person. What you have to have is capability as the basis for your confidence. So we need to think more in education about how to move classroom practice of teachers from making students interested in math or believing that it's valuable to one where we actually help them become competent. And sure, we might need intrinsic interest to get them started, but we actually have to move to greater competence. So we might use extrinsic interest. It's valuable, it's important, you should be interested in this, but we shouldn't stop there. And if I've understood Pat Alexander's model of domain learning correctly, it would be that you develop competence, expertise, and knowledge, and that generates intrinsic interest. So if we want students to get to intrinsic interest, and I think we do, we need to give them tools to become more competent. And I'm really confident in saying this when we see 12 diverse societies over 20 different periods at 2 different grade levels, we're seeing very similar patterns. Well, classical cluster analysis is not the end of this mechanism of classifying. New techniques have been developed called latent profile analysis or latent class analysis, depending on whether you're using continuous or categorical predictors. And it uses Gaussian finite mixtures with covariant structures, and oh my God, it's really fancy. And there are softwares for doing this in R. It would be really interesting to know if we get similar results if we used a more advanced clustering technique. I'm hoping to find out soon because my student Yifei Wu is using mClust, which is a latent class analysis, profile analysis package in R with the TIMS science data. So I hope we can be able to do a comparison study and say, how different would the result be? Do you need to move to the fancy technology, or can you just stick with the old-fashioned methods? So, thank you very much, and I hope that you will use this as a teaser to go and download this book, which is free. And I'm more than happy to take any questions or comments.
Terrific. Thank you so much, Gavin. That was wonderful. Yeah, I think cluster analysis is a fascinating technique, and yeah, as you set it up, in the case of having a set of variables that themselves, at the bivariate correlations, there weren't strong relationships, but somehow putting them together, configuring them, clustering them together could shed some light. And yeah, going beyond just the low, low, high, high, that mix there, and that's kind of really where the action is. I myself have several questions, just because I think it is a fascinating technique, and but I'm gonna defer to others first, though. I'm not sure how to do that in here. I have to admit. If somebody could just turn off. Does anybody have a question? I don't see how I can get you to raise your hand per se. Gavin, do you know how to do that, or is it just
at the bottom? I'm going to stop sharing my screen so that these tools become easier. At the bottom of the screen, there is a chat box, or you can just switch your microphone off and say, jump in.
Yeah. Does anybody have a question? You just want to turn your mic off and chime in for us?
No questions. All right, Jason, you asked your first.
Hang on.
Okay, go ahead, Penny.
No, I don't really have a
Penny, good to
question,
see you.
Gavin. I nearly jumped in when you were starting to point out the gender, the interesting gender patterns, but that was it. That's what I found so very interesting.
Yeah.
And yeah, it's a bit scary.
Well, that's when you allow people options in society, they don't always do what you think they should do. In Sweden, they want girls to do STEM, but girls don't have to do STEM, so girls choose more classically conventional options instead of doing STEM.
And presumably they can earn similar
A good
amounts
life.
of money by doing
they
that.
might not earn as much money or the same amount of money, but because of the social welfare system of Sweden, they can have a really good life.
Yeah. Whereas in Iran, if you don't get involved in a STEM subject, your future is
much more constrained.
severely compromised. Yeah,
much more limited.
Okay, yes, I've read that somewhere too.
And in societies where that's true, what you'll see is a lot more young women going into STEM subjects. So it's not just Iran. It just happened to be that we had access to Iran data, and then we found the result that they were the anomaly, and so we started doing some post facto search in the literature and went, oh, maybe what we're finding is true.
Yeah, I read that. Maybe, I'm not quite sure, it could have been Hofstadter's work or it could have been Wilkins. But I've read that theory, and you have helped me understand the reason for that hypothesis. So thanks very much.
Welcome. Anyone else with a question or comment, or should Jason just pose one?
As I think,
I've got a question.
Methodological one, that just is a student might ask, is if we're used to using variable-centered analysis, and if we get a sample from a different country or sector, in your case here, we would want to do a multi-group confirmatory factor analysis to make sure we had measurement invariance. And so then you think about the analog here, it's like, well, shouldn't I have a cluster solution that I'd have a single cluster solution, and sure, you could then treat sector as a dependent variable, like you did gender or something, and see if countries line up. But is there not a universal solution here? Yeah.
Well, there's two things to say about that. Classical cluster analysis does not provide you any really strong tests of fit. And whether you should expect consistency in how people evaluate themselves in math across different societies is something that, as someone who's done some cross-cultural research, my research consistently says everything is different according to the society you're in.
So yeah,
so I wouldn't expect a universal
that
solution.
first issue, there not being really a technique for that. Is that where that new latent class analysis or profile analysis probably has some of those techniques for?
Yes, exactly.
Sorting
so that's why But IEA was just happy to have someone do something different with their data that others hadn't done. And so they were quite happy to have, well, do an exploratory study and we'll pay you for it. Thank you very much. So that was really nice that they were open to, well, no one's looked at it. So I guess now that we've looked at it, I would hope that the next people doing this would use a stronger technique.
Yeah. My final comment or question, and I'll see if it is just the naming of the variables. You know, as you acknowledged, you know, they do seem to come from a cluster of potential theoretical frameworks. And
Yes.
so I look at something like, you know, well, you called it value. Really, those items are more kind of utility value, specifically as opposed to the, you know, the broader task value construct or attainment value, intrinsic interest. But I think, you know, as I heard you talk and thinking about those items, I wonder if the results almost they would make equal sense, I suppose, but tell a slightly different story if instead you thought about it from self-determination theory perspective and said, you know what that confidence is really that's in a way you're tapping really their past performance in one essence, but also I would say it's really identified or integrated, right, motivation and therefore autonomous regulation. Whereas I see the utility value, oh, my parents say I should be good, society says this is important for me to do well, and that's all right, external regulation, right? Or controlled regulation, as DC and Ryan would call it.
Sure.
So there's just another way of labeling those constructs, I suppose.
Absolutely.
Similar,
and
but yeah.
We didn't impose that on the TIMSS data because TIMSS itself didn't have a clear theoretical mindset when in 1995 they launched these surveys and thought, oh, well, let's add some questions about what the students think about math and science. Well, what shall we ask them? I'm sure they sat around around having coffee and on the back of an envelope said, let's ask these questions. And then as time went on, they said, well, we should ask better questions than that. So I think that we're a victim of, well, at least they asked some questions, but they didn't have a strong theoretical framework for when they asked these questions. But yeah, go back and reanalyze and restructure that. So we were more interested in the data analysis than the theoretical framing. But a theoretical reframing would probably be very useful.
Yeah, I mean, I myself probably wouldn't do, but I would think that just treating that confidence as really kind of autonomous regulation. The value is really, you know, external controlled regulation, and it might be interesting about it from that perspective.
And as an educator, what I suspect and fear we see in teaching is a lot of emphasis on value and liking in schools and not enough on competence. And my one wish out of this book is that teachers would stop kidding themselves and the parents and the kids by saying, well, it's good, at least he knows it's valuable, or at least he likes it. I don't think we should care about that very much. That's a secondary concern. The first primary
come on, but those are
those
high clusters. That value is high, so you're taking that as a given. And you're right. You know, compared to when it's there, compared to confidence, as it's labeled here, might be better. But I would, you know, if we removed value altogether from the equation, those clusters wouldn't be those clusters. So there's an argument to say that it matters, but it's relative emphasis, I think, is the you're getting at. Is, you know, really we should be concerned with, you know, building competence, because that leads to confidence and achievement. It's whether or not they like it. Sure, we'd like them to like it, and maybe we can help them like it. But because of, you know, we want to enjoy what we do. You know, better.
Sure, I want that as a consequence, an outcome of competence,
as it should be. Another comment or question. I'm also glad to see Ian has joined us from the United States. Himself probably self-isolating, and I just wanted to acknowledge him. He is the past convener of this group, and you know, has played as a mentor role in helping me get going here as the convener now. So thank you, Ian.
Esther, did I hear you start to ask a question?
Yes, I was wondering if I could ask a question. Can you hear
Please.
me?
Yes,
Yep.
just.
Cool. So I noticed that some of the conclusions you were drawing there at the end, it seemed to be more causal than associations. And from what I've heard of I don't know lots about cluster analysis, but from what you've described, it seems more like a correlational technique. Like, I just thought what your thoughts are about that.
Absolutely. It's exploratory. It's throwing data in the air and seeing where it lands and taking advantage of correlations. Absolutely. But is it causal proof? No. But it is a causal claim based on my way of thinking about what the data is saying. So an experiment, setting up an experiment where you can say, well, let's try to increase their value. And in this group, we'll try to increase their interest. And in this third group, we'll try to increase their self-efficacy and see which group does better and how those interventions affect those variables. That's needed. Absolutely. But I want to say that when you see a pattern that looks this common across so many time points and across so many grades and so many jurisdictions, you got to start to think, why is this happening? What would cause this to happen? If we assume that the result is real, that we're describing reality, I have to start speculating and imagining mechanisms by which this could have come true. And so my causal interpretations are my speculative attempts to make sense of what could have caused this. And as a scientist, I admit I'm making a causal claim, but I don't have causal proof. Go and do that experiment for me, please.
Any other questions or comments?
Gavin, hi, this is Ian here. Can you hear me?
Hi. Yes, very clearly.
I know that there aren't any fit statistics with cluster analysis, but as you were showing me the profiles within sector, I kept on asking myself the question of, you know, what's the magnitude of the relationship within sector, between clusters and achievement? And is there any metric or any way we could understand or convey the size of the relationship?
Yes, what you see is the superscript, the letter ABC,
Yeah.
is the post hoc analysis of the pairwise comparisons. And what it shows is which groups are statistically significantly
Right.
different. So when you see an A and then a B, you know that those two are differ by more than chance. And so you'll see some of them are A and then B, B, and then C. So those all indicate post hoc that the mean score differs from the other groups by more than chance.
But I think
It doesn't
he's
tell
asking
me
for like
anything
the
about
partial
the
A to,
magnitude.
A to square value or something like that
right.
from that analysis. Sorry. Ian.
No, sorry,
No, that's my question.
we didn't throw that in. Well, no, we didn't throw those in. We thought that when you look at, the thing is, you can eyeball it because Tim's scale, math scale, has a standard deviation of 100. So you can work out the effect size between A and B by just subtracting the two and dividing by 100, and that'll give you a D.
And there were cases essentially where there was about 100-point difference, right, between the low and high clusters, and even more in some cases. You know, right? It's that'd be a large effect, a full standard.
And generally, year-to-year gains in school are sometimes as low as D.20, 25. You know, like year-to-year gains are small on average. If you look at, as an example, look at the ASTEL norms. Sometimes the year-to-year gain in the ASTEL norms is only just bigger than the standard error of measurement. So a difference of 50 points might represent 2 years learning.
Yeah, 2 years of school. All right. Other questions or comments before we disband today? All right. With that, I want to thank Gavin first and foremost for being our inaugural speaker this year. Yeah, round of applause. There you go.
Thank you.
And we do not have a second speaker yet scheduled, but I will certainly plan to do so. Yeah, give me some. If you have any other questions, comments for the good of the order and for the group, please email me directly. Gavin has provided a URL there for the book and the talk, so you can get that there. And once again, thank you, Gavin, and thanks to all of you for being here. We'll
Thank you.
again next time.
My pleasure. Thank you very much. Bye.
Thank you.
All right.